All right, today we're going to talk about orbital notation. And orbital notation is similar to electron configuration. It's just a different way for us to represent where the electrons are when we're talking about this quantum mechanics model, when we're talking about where electrons have a high probability of being in an atom. Now, when we were doing electron configuration, we were just kind of writing a story about what energy level we were on, what sublevel we were in, and then how many electrons were in that sublevel per element. Now when we're doing orbital notation, we're being a little bit more specific. We are showing what the electron looks like, and we are showing what specific orbital it is in a sublevel. And I'm throwing a lot of vocab at you, but I'll explain it all. So we are going to call each of our different blocks on our periodic table sublevels. So we have an S sublevel, we have a P sublevel, a D sublevel, and an F sublevel. And within each sublevel, we have a specific number of orbitals, and that's based on whether it's an S, a P, a D, or an F. So if we go back to our periodic table, when we talked about all of our different blocks, we noticed that there were 2 columns in the S block, and that meant that we had 2 electrons that can fit into the S block. So that's why every time we did an S element, so like sodium or magnesium, there was only a maximum of 2. When we did the D block, we said that there were a maximum of 10 electrons. When we did the P block, we said that there are 6 electrons. And when we did the F block, we said that there were 14 electrons. Now we're going to use that information because when we are looking at our sublevels, we have something called orbitals. And our orbital is going to be this horizontal line. And on each orbital, we can fit 2 electrons. Okay, so if 1s only has 1 orbital, we can fit 2 electrons on it, which is exactly the number of electrons that are in the S block. Same thing for P. So we said that the P block has a maximum of 6 electrons. So if each orbital can fit 2 electrons in it, that means that we now have 3 orbitals that are part of the P block, so we can fit all 6 of our electrons. So again, our S can have a max of 2, P can have a max of 6, D has a max of 10, and F has a max of 14. So these are electron numbers. And then if we're thinking about our orbital numbers, we divide that by 2. So all of our S orbitals are only going to, all of our S sublevels will only have 1 orbital. All of our P sublevels will have 3 orbitals. Our Ds will have 5 orbitals, and our Fs will have 7 orbitals. Okay, so our orbital is just a specific spot where an electron has a high probability of being. So we represent it with horizontal lines that we can place our electrons on. In this model, we are representing our electrons with arrows, arrow-looking things. They're like half arrows. So if something in our 1s has both electrons, we put 1 electron up and 1 electron down. We have to remember that electrons are all negative. So negative things don't really like to be next to each other. So in order to make these electrons be next to each other, they have to be facing opposite directions. Okay? Now you might have noticed that when I filled in my 2p sublevel, I filled across first and then doubled up. So I'll show you how I did the D. So we always fill across a sublevel first, before we put a second one in, going back to the reasoning that electrons are all negative, and so negative things don't want to be next to each other unless they have to. Well, if we have to add more than 5 electrons in a d sublevel, well, we have to double up, we just put them in a different direction. Now, we always fill from lowest energy to highest energy. So we can't fill in here and then here. We have to go in order. So we go in order from lowest sublevel to highest sublevel. And then when we're in the sublevel, we go in order of orbitals. Okay, so we're going to do some practicing. So the first example that we have is lithium. My suggestion is to first write out your electron configuration until you get used to doing this. So if we think about our electron configuration for lithium, we want to find it on our periodic table, and it's right here. So remember, we always start from the beginning. So we're in the first energy level, and we go all the way through that first S block. So it's going to be 1s2. And then we find lithium, it's the first one in our second energy level, again in the S block. So second energy level, S block, 1 column. So that would be our correct electron configuration. So now translating this into orbital notation, every time we see an S, we put 1 horizontal line, and then we label the sublevel that it is. So it's a 1s. Now we have another S. So again, we put 1 orbital line, and we label it the sublevel that it is. So we have 1s and 2s, and that's all for this orbital notation. Now, we talked about in electron configuration how the exponents were electrons. Well, in orbital notation, our electrons are the arrows. So if I have 2 electrons in the 1s, I put 1 facing up and 1 facing down. Then in the 2s, I have 1 electron, so it faces up. So now I have 1, 2, 3 electrons, 1, 2, 3 electrons, and I have completed lithium. Let's do carbon next. So go ahead and do the electron configuration for carbon, keeping in mind that it's over here, so we have to go all the way through the 1s, the 2s, and then we're in our 2p. Okay, so the correct electron configuration for carbon would be 1s2, 2s2, 2p2. Now we're going to think of this the same way we thought of for lithium. Every time we see an S sublevel, we're going to put 1 horizontal line and label it. Okay, now we have another S, so we put 1 horizontal line and we label it. Now for P, there are 3 orbitals in every P sublevel. So every time we see P, we draw 3 horizontal lines and then label it. So now we start across. We always start from our lowest energy to our highest energy. So 1s has 2 electrons in it, so 1 up, 1 down. 2s now has 2 electrons in it, 1 up, 1 down. And then 2p has 2 electrons in it. So, like I said before, we fill across so that the electrons don't have to be next to each other. But we always go from lowest energy first. So we put 1 in the first orbital and 1 in the second orbital. It's also important that they're facing the same direction. Okay? It is okay that we have a blank spot there. We're going to leave it there. Don't have any orbitals that are floating away. We need the entire sublevel to be there. Okay, I just have a few more practice problems so you kind of get the hang of it. All right. Here we have aluminum. So again, let's go ahead and write the electron configuration first until we get really used to it. So aluminum is in our third energy level and our P block. So let's go ahead and write out the electron configuration for it. All right. Now, underneath it, we're going to start writing our orbital notation. So we have 1s, which is 1. Okay, then we have 2s, which again is 1 orbital, and we label it. Now in our P sublevel, we need 3 orbitals, so 1, 2, 3, and we label it. And then we have 3s, so that's only 1 orbital. And then we have a p again, so that is 3 orbitals. Again, notice how I'm labeling them with the energy level and the block. Now I fill across. So 1s has 2, so 1 up, 1 down. 2s has 2 electrons, so again, 1 up, 1 down. 2p6, there are 6 electrons. Remember, I fill across in a sublevel first, and then I double up. 3s2 has 2 electrons in it, so 1 up, 1 down. And then 3p only has 1 electron in it, so I go up in just the first one. Okay, let's try nickel now. Nickel is in our D block, so we have to do our entire electron configuration getting to nickel. Again, once you get used to doing orbital notation, you don't have to do your electron configuration first. It's just a good way for us to practice and make sure that we're not leaving out any other sublevels. So go ahead and write your electron configuration all the way to nickel. All right, make sure that's the electron configuration you got. Remember that your D block is 1 behind, so if you have 4s, 3d is next. So now I'm going to start creating my orbitals. My s is 1, my next s is 1. Remember, this is 1s, 2s, then my p is 3, and I label it 2p, and then my s is 1, my p is 3, my s is 1, and then here I need to go on another line for my D. My D is 5, because remember there's a maximum of 10. So 1, 2, 3, 4, 5, and I label it 3D. Okay, so now I start filling them in. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Those are all totally filled sublevels. So we can quickly just fill those in with electrons, because we know that they have maxed out. Okay, now we get to our D. Now we need 8, so we go 1 up, and we fill across first. Okay, and that's 5, and we need 3 more, so the first 3 orbitals in our sublevel will get additional ones. And that's orbital notation.